Okay, so we're going to start into a few lessons we're going to do here for about a week on proportion. Um, this is really relevant for everybody. It's most specifically taught in all of Math 026, 038, and 052, and I've listed which sections today's lesson is from for those. But for Math 053, it is also expected that you can do this. So this is a specific type of equation and word problem that will continue to come up. And I made a little note there that a lot of people assess into Math 053 based on the Camosun assessment system. And if they do that, they never actually, a lot of them actually don't get taught or learn the proportion stuff. And therefore, they got to try and figure it out as they go along. So especially for those who haven't actually taken 052 but are in 053 from an assessment, this is still very, very relevant and helpful. It also slots right into the equation solving chapter. A lot of it does in terms of the types of word problems that'll come up with proportions and percents, and in terms of a very special type of equation that you will run into. This is for everybody. You will run into this over and over and over in different math courses, and there's a quick way to solve it instead of kind of plodding through the long equation solving method. For Math 026, 038, and 052, in those chapters that we've mentioned there, this very, very specifically is basically every equation you run into in those sections will be of this type. So, quick little review, reminder on ratios, fractions, and reducing. So, a ratio is just when we compare two values, usually that have the same units, although we'll see we can write ratios that have different units as well. We use a colon between the numbers to represent a ratio. So if you have a recipe that says use 5 cups of flour for every 2 cups of sugar, then we could write the ratio of flour to sugar as 5 to 2 is how we would read that sentence there with that colon in between. So maybe the recipe itself says use 5 cups of flour and 2 cups of sugar, but you want to make a double batch or a triple batch or something like that, or a 2.5 times batch, then you can work with that ratio to figure out how much flour and sugar to use. Here's another one. For every 15 laps that Liang runs, Janice runs 20 laps. We're going to write the ratio of, this is running laps on the track, I'm assuming. So Liang's 15 to 20 for Janice's. So there's Liang's laps on the left and Janice's on the right, 15 to 20. A ratio is actually just yet another way to write a fraction. We've seen a whole bunch of them so far. Decimals are fractions, percents are fractions, ratios are fractions. So if we look at the 5 cups of flour to 2 cups of sugar ratio we just talked about, 5 to 2, that is actually, we also can write that as a fraction, 5 over 2. And Liang's 15 laps for Janice's 20 laps, 15 to 20. We can also write as the fraction 15 over 20, which we realize reduces since the top and bottom both divide by 5. So that the ratio of 15 to 20 is actually the fraction 3/4. And that means that the ratio 15 to 20 is also the ratio 3 to 4. So if Liang is running 15 laps for every 20 laps that Janice runs, then you could also say that Liang is running 3 laps for every 4 laps that Janice runs. It's the same ratio. And if you multiply those both by 5, you'll see that they are the same thing. Once Liang has done his 3 laps 5 times and Janice has done her 4 laps 5 times, they have done 15 and 20. Yeah, for every 3 laps Liang runs, Janice runs 4. I pulled Liang out of the hat. That was one of my friends in high school, that name. And Janice was a student I taught who was a very good runner, which is why she made this question. So we can see that ratios can be reduced in exactly the same way that we reduce fractions. We didn't have to make this a fraction, then reduce to 3/4. We could have just looked and said, oh, 15 and 20 both divide by 5. So that reduces to 3 to 2, the ratio 3 to 4. Okay, so here's a couple unreduced ratios. I'd like you to take those, write them as reduced ratios, and then also as reduced fractions. I'll give you just a minute to try that. Just quick little reductions, see what number divides out of both. So let's take a look at these. So we have 14 pounds of gravel for every 35 pounds of concrete. I think that's well, no, that could be a ratio that we would use if we're mixing up some concrete. So that is the ratio 14 to 35. Let's. It asked for reduced ratios first. So let's reduce this ratio without even going to the fraction. We can see that 14 and 35 can both be divided by 7. So 14 divided by 7 is 2, and 35 divided by 7 is 5. So the ratio 14 to 35 is the same as the ratio 2 to 5. And as a reduced fraction, that would be 2/5, like so. So again, exactly the same as working with fractions. Anything that divides out of both of them, you can do. Levi sells 30 pairs of jeans for every 24 t-shirts. I'm sure that's incorrect. I just made it up. That is the ratio 30 to 24. So 30 jeans for every 24 shirts. You can see both divide by 6. So 30 divided by 6 is 5, and 24 divided by 6 is 4. So that is the reduced ratio is 5 to 4. And for every 5 pairs of jeans Levi sells, they sell 4 t-shirts. And we can also write that as a fraction when we need to. 5 over 4, same thing. Oh yes, and I spotted the 6, you might have instead spotted that those are both even numbers, 30 and 24. You would have divided them by 2 and got 15 and 12, but then you would notice that those are also divisible by 3. 15 divided by 3 is 5, 12 divided by 3 is 4, so you would still get to the same answer. So just like fractions, once you've done one step of reducing, double check, because you might have missed something bigger that comes out of both of them, so keep reducing until it is in lowest terms, nothing comes out of both 5 and 4. If a ratio has decimals in it, this will be nothing new. We've also dealt with decimals in fractions. If we want to write that as a fraction, we remember our little trick that we use to get decimals out of fractions. So for example, we have the ratio 8.2 to 0.46. There it is written as a ratio. There it is written as a fraction, 8.2 over 0.46. When we want to write a fraction, we do not leave decimals in that fraction. So I'm going to remind us that 8.2 is the same as 8.20. Why did I do that? Because now both the top and bottom have 2 decimal places. They go to the hundredths. So if I multiply them both by 100, that moves the decimals 2 to the right, and we get 820 on the top and 46 on the bottom. So we match the number of decimal places, multiply by 10 or 100 or 1,000 or 10,000 or whatever it is to make those decimals go away, and then reduce that fraction. I think they're both even, and that's it. 410 over 23. And you could turn that into a number as well, although generally when we're dealing with ratios, we don't go to mixed numbers. It kind of takes us further away from what we want to be doing. So decimals, write it as a fraction as normal, make them both have the same number of decimal places so you can multiply and get whole number fraction. When they ask for a fraction, they do not want decimals in the fraction. So why don't you take 1 minute and try this one right there. Take that ratio, write it as a fraction, then get rid of the decimals. Okay, 0.18 to 1.2, there it is as a ratio. And that, we literally read that as 0.18 to 1.2. There it is as a fraction with decimals in it, which we don't like. Top has 2 decimal places, the bottom has 1, so I add a 0 to the bottom one to make them both have 2 decimal places. Multiply top and bottom by 100, because that gives me a fraction without decimals, which is what we want. And then, of course, we always reduce, so 18 over 120 reduces to 9 over 60 when we divide top and bottom by 2, but look carefully, top and bottom also now divide by 3, so I get 3/20. So that's, I mean, you see now it's a bit surprising, right? You never would have guessed that the ratio 0.18 to 1.2 is actually the same as the fraction 3/20, but it is. So in this case, we didn't notice that we could have taken 6 out of both of them, so we took a 2, and then we saw, oh, we can go further with the 3. Either way, you will end up at the same answer of 3/20 for your fraction. If a ratio has fractions inside of it, don't panic. Just do the same thing you always do. So here is, oh, this one looks ugly. Don't panic. It's going to be fine. 2 1/3 to 5 1/4. Well, let's write it as a ratio. There it is as a ratio, 2 1/3 to 5 1/4. And I'm going to turn those into improper fractions, 7/3 and 21/4. And now when I decide to write that as a fraction, that will become 7/3 on the top and 21/4 on the bottom. Again, don't panic. You know how to do this. What do we do when we have one fraction divided by another fraction? We remember that division of a fraction is multiplication by the reciprocal. So we turn the divided sign to a times sign, and we flip the second fraction. Okay, so when you see this ugly looking thing here, don't worry, you know exactly what to do. Turn them into improper fractions, write the ratio as a fraction, and then do your fraction division rule. And what do we get? Oh, we're going to do a little canceling here. Remember, we can only do the canceling between fractions when we are multiplying, which we are in this case. So I can do some simplification. The 21 and 7 can both be divided by 7, leaving 7 divided by 7 is 1, and 21 divided by 7 is 3. Now do your multiplication. 1 times 4 on the top is 4. 3 times 3 on the bottom is 9. And if you didn't do your simplification first, you could always do your simplification after. It's just sometimes the numbers will get really big and ugly, so it's better if you can reduce first. Okay, so again, a bit of a surprise, right? 2 1/3 to 5 1/4, that ratio there, not immediately obvious that when you express that ratio as a fraction, it's actually 4/9. Or in other words, this ratio is the same as the ratio 4 to 9. Okay, so there's some just of the mechanics of working with ratios. Now we're going to pull percents in here because percents are also fractions, which means they are also ratios. So 71%, remember, per 100 means 71 over 100. So that is a ratio, 71 to 100. 45% means 45 per 100. Now that one looks like we can reduce, divide top and bottom by 5, and we get 9/20, which means 45% is the same as the ratio 9 to 20. And what we're thinking here is kind of like the part to the whole, and we'll get to that not today, but in, I think, the next day's lessons. 45% out of 100 is the same as 9 out of every 20. Is the way you can think about that. 250%, we don't care. We can have percents that are bigger than 100. They usually express something that has grown, something that's gotten bigger, right? The economy grew by 250% over the last, well, that's a lot for an economy to grow, but maybe a company's stock price might grow by 250% if they're really on fire. 250 over 100, both top and bottom divide by 50. We get 5 over 2, or you might have noticed top and bottom divide by 10 first, and then you could have gone further and divided by 5. Either way, you will end up with 5 over 2. So as a ratio, 5 to 2. So there is percents turned into ratios. And let's see, we want to turn these ratios into fractions, decimals, and percents. So 3 to 10 means the fraction 3 over 10. 14, I'm going to do the fractions first because they're easy, right? There's the fractions. 14 to 25 is 14 over 25. 23 to 8 is 23 over 8. Now, how do we get these into percentages? Recall that we actually already learned how to turn fractions into percents while we were doing our review unit. We had to do long division at that point, but hooray, if you're doing this chapter in Math 052 or 038, or you're in Math 053, you no longer need to do this particular one with long division. You can just pick up your calculator and divide. 3 divided by 10 is 0.3, and we want to turn that into a percent. Just remind ourselves that 0.3 is the same as 0.30, right? So when you move that decimal 2 to the right, 0.30 is 30%, same 0.3 is 30%. If you're in Math 026 and watching this, Unfortunately, you do not yet have the use of a calculator on your test, so you do have to make sure you know how to do these by long division still. And I would say even those in higher grades, use your calculator, but every once in a while do one by long division just to keep it fresh for yourself, if in case you ever need it, which you will from time to time. 14 divided by 25, again, if we punch that in or do the long division, we get 0.56, which is move the decimal twice, 56%. 23 divided by 8, you get 2.875. Move the decimal 2, 287.5%. So again, much easier to turn fractions to decimals and percents once you have the use of a calculator, for sure. Okay, so we've just now ratios, fractions, decimals, percents. We've learned to transfer them all back and forth. The last little idea we want to talk about in this little first introductory lesson is the idea of a unit rate, which is essentially when we make the second part of a ratio into a 1. We call it a unit rate. And usually we just say rate, actually. So you can think of unit rates as per statements. So what do I mean by that? 50 kilometers driven per hour. Well, you can write that as a ratio. Those are unit rates already. We could write it as a ratio of 50 kilometers to 1 hour. And 3 eggs per batch, we can think of as 3 eggs to 1 batch of cookies. And so when we read these initial statements here, these were rates. We don't bother with the 1, right? We usually don't say 50 kilometer driven per 1 hour, even though it's implied. 50 kilometers per hour. See, that's what I mean when I say these are per statements. We don't say 3 eggs per 1 batch of cookies. We just say how many eggs do you need per batch? 3 eggs per batch of cookies. So that's the idea of a unit rate. So whenever a question asks you for a rate or a unit rate, what you really need to do is don't just write the ratio. This is very common. So listen here, up here, very common that people will be asked for the rate and they write the ratio, meaning they don't make the second piece of it equal to 1. So we can take any ratio and turn it into a unit rate, or a rate, we just say, by just dividing the first piece by the second piece. So let's imagine, these are actually the same as the last 2 examples we did, but let's imagine instead of giving you the information the way I did, 50 kilometers in 1 hour, what if I had said you drove 150 kilometers in 3 hours? And then they say, what is the rate? Well, there's the ratio, 150 kilometers to 3 hours. Divide the first one by the second one. In other words, divide them both by 3. And that becomes 50 kilometers per 1 hour. That is now a rate, 50 kilometers per hour. So if they asked you for the rate, this last sentence here is what you would say. You get there by looking at the ratio and dividing it down so the second piece is equal to 1. 21 eggs to make 7 batches. So there is the ratio, 21 eggs to 7 batches. Divide them both by 7 so that the batches become 1. In other words, force the second one to become 1. And you get 3 eggs to 1 batch. So what is the rate? 3 eggs per batch is the rate. The rate of how many eggs per batch you need based on this information that was given to you up here. They don't have to work out nice like that. So let's see, an old washing machine used 1,247 gallons of water to do 40 loads of laundry. A new washing machine used 2,570 gallons of water to do 210 loads of laundry. Okay, numbers floating around everywhere. What is the unit rate of each machine to 2 decimal places? Let's break it down. Let's look at the old machine first. 1,247 gallons to 40 loads. There is the ratio for how much water for how many loads of laundry. To get the unit rate, we want to force the second piece to be 1. So we divide them both by 40. And it breaks down to 31.175 gallons to 1 load. which we can write as a unit rate, a per statement, 31.18 gallons per load. And you notice we were asked to round our answer to 2 decimal places, which is why I changed the 0.175 to 0.18, rounded that 7 up to 8. Okay, so you see how we do unit rates. We take the second number, we divide both by it, which forces the second number to become a 1, which is the whole idea of a unit rate. Now let's look at the new washing machine. Oh, you're going to try this one. So follow the exact same process as we did on the old washing machine to find the unit rate of water used per load for the new washing machine. We look at the numbers for the new washing machine. It used 2572 gallons of water to do 210 loads. So there is the ratio of water to loads of laundry. We want to not reduce this, right? We could also reduce this rate to lowest terms, this ratio, sorry, to lowest terms, but they don't ask us to reduce the ratio to lowest terms, which we would do by, we'd start by dividing them by 2, and then we'd see if there's anything else that comes out. That's not what they want us to do. They want us to force this into a unit rate, right? So 2 different questions. Reduce the ratio to lowest terms is like reducing a fraction. Find the unit rate. You don't care if it reduces nicely or not. You just divide by that second number so that you can force the second number to be 1. So I divide both by 210. That forces the second number to be 1. And now I know how much water per load. Again, remember, rates are a per statement. Kilometers per hour, gallons per load, eggs per batch. And we get them by forcing the second number in the ratio to become 1. 12.25 gallons per load. You can see the new washing machine uses a lot less water than the old washing machine. And I think I pulled those numbers from the real world, actually. I Googled some information about old and new washing machines. All right, let's see. Smriti is at the hardware store and sees that she can either spend $11.68 for a pack of 250 drywall screws or $19.25 for a pack of 400 drywall screws. Which is the better deal? In other words, which one is she paying less per screw? So let's look at them separately. The pack of 250 is $11.68 to 250. Like so, $11.68 to 250 screws. I am going to force this into a unit rate, which in this case, because we're talking about money, we also usually call a unit price. Might be the other way you hear this described. So I divide both by 250 because it forces the second half of the ratio to be 1. Even though the numbers aren't nice, again, if you were asked to reduce this ratio or write it as a fraction, you would be doing an entirely different thing. You would be finding things that are common and breaking it down to lowest terms. So it looks like Smriti is paying, let's see, $0.04672. So that, in other words, is about 4.672 cents per screw in the 250 pack. And all right, so you try the second one. Same process. The 1925 for 400. See what the unit price is for those ones. Okay, so let's take a look at the second pack. $19.25 is the ratio to 400 screws. I'm going to force the second number to be 1. So I have a rate per 1 screw. I hope I actually wrote the rates. I did. Yeah, I did. Yeah. So the unit price or the unit rate or the rate, we can call them all these different things, or the cost per screw for the 250 pack is 4.67 cents. And for the 400 pack is 4.81 cents. Well, that's more, right? So this one, the 400 pack, contrary to what usually happens, usually the bigger ones are cheaper per item, but in this case, that's actually the cheaper price per drywall screw. So the 250 pack is the better deal. That is called unit price. It's really just the same thing as unit rate, but when we're talking money, they will describe it in the questions to you as unit price.